Hi, this is our paper, Teach a Robot to Fish, Versatile Imitation from 1 minute of demonstrations. In this work, we provide a robot with 1 minute of expert demonstration and propose our algorithm, fast imitation of skills from humans or fish, which generalizes to different object configurations and types with minimal online learning. We evaluate the versatility of our approach by running it on 9 tasks across 3 different robot morphologies. Let's look at what goes wrong with offline imitation. Consider the task of flipping a bagel. We collect a single minute of expert demonstrations and perform offline imitation on these demonstrations. We observe that in such low data regimes, these offline imitation methods suffer on different object configurations. We further evaluate these methods on new objects unseen in the expert demonstration and observe a further dip in the performance. As a solution to this problem, we propose combining offline pre-training with online correction. Our method starts with using behavior cloning for representation learning. Given a minute of expert demonstrations, an encoder converts the observations to an encoded representation, which are then passed through a BC policy to obtain an action. We observe that in such low data regimes, such a policy fails at performing precise actions necessary for the task that we want to perform. So instead of using the BC policy, we use the encoder from this BC model in order to obtain a non-parametric base policy which, given an observation, provides us with the base actions. In the second phase of our method, corrective residuals are learned on top of these base actions using inverse RL. Thus, given an expert and an agent trajectory, an encoder is used to convert them to a trajectory of encodings. Optimal transport-based trajectory matching is used to obtain a similarity score between these trajectories. This score is used as a reward to learn the residual policy using reinforcement learning. So let's put it all together. We start by collecting a minute of expert demonstrations and perform representation learning on the demonstrations using behavior cloning. The encoder from the trained BC model is used to obtain a non-parametric base policy, on top of which corrective residuals are learned using optimal transport based inverse RL. Let's go back to the task of flipping a bagel. We observe that fish is able to generalize to different object configurations, achieving 90% success with less than 20 minutes of online learning. We evaluate our method across 3 different robot morphologies: the Allegro hand, which is a robotic hand, the Hello Stretch, which is a mobile robot, and the X arm, which is a robot arm. On average, we observe a 3.8 times better performance as compared to prior work. Interestingly, fish is also able to generalize to new tasks that are unseen in the expert demonstrations. Consider the task of picking up a dollar bill. Given this demonstration, we observe that fish is able to generalize to different types of bills as well as different colored cards. However, for cases with large variations such as a wallet, fish fails at performing the task. A similar observation is made on the task of flipping a bagel. Given a demonstration on a specific type of bagel, fish generalizes to different types of bread. However, like before, it fails on the flat bread, which is soft, and renders the strategy showed in the demonstration ineffective for the task at hand. This is our work, fish. Fish requires just a single minute of demonstration and requires less than 20 minutes of online learning. It learns from images, and the video and open source code are available at the given website. Thank you.